What up? It's Kettle Hut, and welcome back to another Alex homework help video. So today, I strongly recommend you watch this video at least through towards the end because we are going to be doing some things about rate of change that Miss Craig did not go over in the slides. It is a usual thing where somebody makes the homework and somebody makes the lesson, and they don't always coincide. So please watch it all the way through. There's going to be couple questions at the end that are different. If you're stuck on those ones, just skip ahead to the video. I don't have timestamps. I'm making it. Maybe you can figure it out, post it in something, Snapchat or what have you. So find the slope of a line passing through the points, etc., etc. Again, this is just going to be our slope formula. So if you remember the slope formula, you have y2 minus y1 over x2 minus x1. And so we're going to take these 2 points and we're going to label them. This is going to be, I really hope you guys can see the mouse. I came to one of the other videos, I realized you couldn't see the mouse. So 6, -7, -7, and -3. You're going to label these points x1, y1, and x2, y2. So my x1, y1 will be these two. This will be x1, that'll be y1. Maybe I should write this off to the side here. So we have our -7 and -7 is our first point, and our second point is -3, 6. This is our x1, y1, and this is our x2, y2. And all you got to do is plug these points into this equation, and you'll get your slope. So you'll start with y2 is 6 minus y1 is -7. That goes over the top of x2 minus x1. So you're going to put your -3 minus, and again, -7. 6 minus -7, the negative minus a negative turns into a positive, so you have pluses here. So 6 plus 7 is 13. Down on the bottom, -3 minus -7, again, it's a plus. And that -3 plus 7 is going to be 4. And this is as much as you can do with that. So this is going to be our final answer. Chances are Wolfram will do all this stuff for you, but owners of a recreation area are adding water to a pond. The graph below shows the amount of water in the pond in liters versus the amount of time water is added in hours. Use the graph to answer the question. So a couple things to notice. The y-intercept is 2,000 liters. Time in hours goes from 0 to 9. It looks very linear. What does it ask? So how much does the amount of water increase for each hour that water is added? Excuse me. So we're looking at this. We're saying for every time we move 1 hour along this graph, so each grid box, every time we move 1 hour, how much more water is added? We look, let's just check it out. From here, from 0 to 1, it starts at 2,000 and goes to 2,500. And then from 1 to 2, it starts at 2,500 and goes to 3,000. Then from 3,000 to 35, 35 to 4,000, 4,000 to 45. So you start to see the pattern. It jumps up. Every hour it jumps up 500 more liters. What is the slope of the line? Slope is rise over run, so we're asking ourselves how high does this line go up for every single unit that it goes to the right, in this case hours. So for each hour, how much does it increase? Well, we just saw for every 1 hour it increases 500 liters, so the slope will be 500. Now I think these will probably always be the same, but they might give you a weird graph where the bottom has also half hours indicated, and then these might be phrased differently. So you just have to be careful. Fill in the blanks below. Find the slope of the line passing through these 2 points. So this is again more slope formula. I'm not going to rewrite the slope formula, but we can use this again, right? This is still right here. So it's the same thing. You're going to label x1, y1, and x2, y2. Notice both the y's are -9. So we come over here. We have, starting with -7, -9, and then 2, -9. as I said, x1, y1, x2, y2. The formula was y2 minus y1 over x2 minus x1. Plugging this in, you get what? So the y2 is this one, so negative 9 minus y1 is also negative 9. I put the parentheses. It's important to notice that this is a negative and a negative. X2 is 2 minus x1 is negative 7. Negative 9 minus negative 9, that's negative 9 plus 9, that's 0. Those of you that watch the video, Miss Greg does a very good job explaining that this 0 over here on top, well, if this is 0, 0 divided by anything is always going to be 0. So chances are you can jump and straight do this. You should check, does 2 minus negative 7 equal 0? No, it does not, so we're okay. If you divide by 0, it's going to be an undefined slope. I think we might see that in a second. The next one, it's the same kind of story, 5 comma 6 and negative, sorry, not negative 5. Where's my, okay, so then the other one is 5 comma negative 1. So again, x1, y1, x2, y2, same formula. I don't want to rewrite it. Should have it written down. I'm going to do y2 minus y1 over x2 minus x1. And uh-oh, we see if we do this first, the 5 minus 5 on the bottom, that turns into 0. Anything at all ever divided by 0, we cannot do it. There's a really cool explanation about why this is, but it is not possible. So that would be undefined. I'm hoping that's a choice. Ah, yes, undefined. I think you do have to click it. I don't think you can type it. Ooh, this is hard. Okay, so this is where you guys might be jumping ahead. This, I don't think, maybe this did show up in the notes. I'm not 100% sure. I don't remember seeing it off the top of my head. Anyways, the points 2 comma r and 6 comma 6 lie on the line with a slope of 4. Find the missing coordinate r. So you could be trying to do slope formula or point slope or whatever you might want to do. I recommend starting with slope. So we know the slope is m equals y2 minus y1 over x2 minus x1. Okay, then we just start to plug everything in. So first, let's write down everything we know. We know the slope in the given problem is 4. Slope m is always our slope, so m is 4. The 2 points that we have are 2 comma r and 6 comma 6. Now we can tackle this problem because you see we have an x and a y, we have an x and a y. Over here we have x, y, x, y. These are x's and y's. We need 4 and an m, and we have 4 and an m, and we're only looking for one unknown. So this will work out fine. Just plug in everything you know. It's arbitrary to label these whatever you want to label these. I'm, for sake of making things nicer, I'm going to call the 6 comma 6 x1 comma y1. And if you're doing this with me or ahead of me and you labeled these the other way around, it's fine. You called the top point x1, y1, that's fine. It'll still work. Just plug in everything you know. So this starting with the m is 4, and that equals, and then m, we have the y2 minus y1, so we have r minus 6 over x2 minus x1, which, sorry, there's sirens outside, it's freaking me out. So then the x2 minus x1, you have x2 is 2, x1 is 6, so you put in here 2 minus 6. So r minus 6 divided by 2 minus 6 should equal 4. And from this point is an Algebra 1 problem through and through. So to make this a little bigger, ooh, that's a lot bigger, let's not do that. Oh boy, where did it go? Oh, there it is. That is, yes, okay. Okay, we're back. So this is Algebra 1 problem all the way. We're going to solve this by just doing quick math. First things we want to do is simplify the bottom. So you end up with 4 equals r minus 6 over 2 minus 6 is, no points for guessing, negative 4. To get rid of the negative 4 on the bottom, you have to multiply both sides by, shocking, negative 4. So you multiply both sides by negative 4 times this side by negative 4. 4 times negative 4 is negative 16 equals r minus 6. These 4's cancel. That's why we do that. And then to get r by itself, we're going to add 6 to both sides. You get negative 10 equals r. Now you can check your answer not just only by plugging it into the thing over here and checking, but I don't know where my negative went. I use the, okay. So you come back, you can check your negative 10, plug it into the equation to see if it works. If you plug in negative 10 for this r, negative 10 minus 6 is negative 16. And then 2 minus 6 is negative 4. Negative 16 divided by negative 4 is in fact 4. So it should be good. I think this is going to be the, nope. So that's the only one of those that it looks like. So with these, again, just start with the slope formula. Plug in everything you know an x1, y1, you know an x2, y2. They'll always solve. Let's see if we can get one that's going to solve differently, just real quick. So I think that one's going to solve pretty similarly. The only difference is this is a half. Let's just do it. So we're going to do it. You have over here m equals y2 minus y1. I gotta stop hitting that button. y2 minus y1 over x2 minus x1. And then our slope is now 1/2. Our y2, excuse me, our points are 8 comma r and 4 comma negative 6. I'll call this one x1, y1. I'll call this one x2, y2, just because that's opposite how I did before. No, that's how I did before. That's fine. So up here, then you're going to have 1/2 equals, and then y2 minus y1. That's going to be negative 6 is our y2 minus our y1 value is r, all over x2 minus x1. That's going to be 4 minus 8. I think I'm just going to stick with the same method, honestly. I don't know why we would change. It's working fine. So 4 minus 8 is negative 4. And you have negative 6 minus r. That's equals 1/2. To get rid of the negative 4 on the bottom, you do the same thing. Multiply both sides by negative 4. Negative 4 times 1/2, it's going to be negative 2. And again, they cancel. That's why we do it. And then to get r by itself, now I see why we did this. You have to add 6 to both sides, and you get negative 2 plus 6. That's 6 minus 2 is 4. That equals negative r, right? Negative r is still there. And then to get r by itself, multiply both sides by negative 1, and negative 4 equals r. Let's see. So, same thing. I did that one a lot quicker. Pause the video if you need help. This one we can just do graphically, it looks like. Let's see. The graph of the function g is shown below. Use the graph of the function to find its average rate of change. Average rate of change. That's key right there. Average rate of change from negative 2 to 4. So this is something that I'm positive wasn't in the video. Average rate of change. Well, first you have to find how much does it change from negative 2 to 4. So let's start with that before we do average. So if we look at negative 2, here's our negative 2 on the graph. And where is that at? Well, on my graph, it's at negative 9. So we got to kind of keep that in the back of our head. Negative 9. So over here, our first point is negative 2, negative 9. But mostly I'm worried at, it starts at negative 9. And then if we go to the next point, it goes to 4 is the one it asks us for over here, 4. So to go to 4, we're looking at 4 and it goes up to 5. Excuse me, 3. 1, 2, 3. So over here, then it goes up to 3. So the rate of change The average rate of change is what we're asking to see. So first we have to figure out how much it changes, period. So if we start at -9 and we go all the way up to 3, some of you, if you need to count it, some of you, you can, or you can just do math. But if you start at -9, you go boop, 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 boop. You have to go all the way up to 0, and then you go up to 3. So to count it this way, from -9 to 0 is 9. And then you're going another 3 after that. So that would be 12. The other way to do this is 3 minus -9. 3 minus -9 is 12. Or you can just look at the graph graphically and say, we start at -9 and we go all the way up to 3. So that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So that's 12. And you'd be tempted to do this. Chances are that might have been what you've done if you did it wrong. Now the other part of this keyword is average. Average rate of change. So you got to think average. When you do average, you add everything up, divided by the total number of things in the set. So for us, we're saying, yes, it went up 12, but how many units did we have to move in order to go up 12? That's where we look at this. We started from -2, we went to 4. So we're going -2 to -1, 0, 1, 2, 3, 4. That's 6. So we had to go 6 units to the right, and we had to go 12 units up. So find average rate of change, you're going to do a combination of those things. Remember, slope is kind of what we're looking for here, quasi-slope. That's going to be up 12 over 6. So remember, if you put this 12 in here, you actually should put it over 6. But 12 divided by 6 simplifies to 2. Right? So when you do average rate of change, you have to do both of those things. First, figure out how high it went, and went over how far it is. So effectively, you're still doing exactly slope. It's just a fancy name for it, because you notice this isn't a straight line, but it is what it is. That was not in the notes, and I don't think this one was either. So let's talk about this. Oh, it's the same thing. Cool. So average rate of change from -4 to 2. So now we kind of know we're looking for slope. First thing we notice is from -4 to 2, it's going up, right? So it's still going to be positive. How much does it go up? It goes from -8 on my graph, see the -8, all the way up to 4. So you can either count that here, 1, 2, 3, 4, 5, all the way up, or you go from -8 to 0, that's 8, and then you add 4 more, so it's still going up 12. And then we're saying it's average rate of change, so how far to the right do we go? We're starting at -4 and going to 2. Starting from -4, going to 2, 4, and then 2 more is 6. So 12 divided by 6, the same thing. Hopefully they're not all 2. Maybe that's just a fluke. Maybe the answer is always 2 on those. Last things last, I think this is last. Find the average rate of change of this function. It's another quadratic. You guys should remember quadratics. So it has a positive a value of 1 even, so it's going up, right? It's a parabola facing up. To find the average rate of change, you could type this into Desmos and then plug those points in and graph it. That might be the easiest solution. But let's just do it the long way. First, we have to figure out what values these give you. So we need the points. So kind of down here to the side, we know 1 point is 3 comma something. Because when you plug 3 into this function, you're going to get some number. And this is where Desmos will just give it to you right away. Also 6 comma something. And we're going from here to here. So plugging these things in, you're going to do what? First, plugging in 3. So this is just going to be calculator or plug it in by hand or whatever. So I wrote this equation, this exact equation from the problem. The only difference is where the x's were, I left blanks, and I'm going to plug in my numbers here. So my first one I'm plugging in is 3, and then the next one is 6. Okay. So now we're just going to solve those and see what we get. So 3 squared is 9, minus 4 times 3 is 12, and then plus 1. Over here, 6 squared is 36. 4 times 6 is 24, plus 1. Then here we have 9 minus 12 is negative 3, plus 1 is negative 2. So that's our first point. When you plug in 3, you get negative 2, and you should be able to check that on Desmos if you use my equations. And then over here, 36 minus 24 is 12, plus 1 is lucky number 13. Now we're asking for average rate of change, which is quasi-slope still, as we said. Doing it the way we were just to be consistent, you're going from negative 2 all the way up to 13. So to do that, you need to go up 2 to get to 0, and then 13 more. So that's going to be a total of 15 up. That's our rise. And that's going to be over the run, right? So in the x's, we go from 3 to 6. How far is that? That's 3. And then divide it, you get 5. Now, maybe cheese would be a Desmos Aronis. Let's see if Desmos will cheese this for us. Desmos. So to cheese it, quote unquote, cheese it on Desmos, you could do a handful of things. First, you're going to type in the equation 6x squared minus 4x plus 1. So there's our graph. The points that we're worried about are x equals 3 and x equals 6. So I think we can do this, convert it to a table, and then you have your 3 and your 6. And there's our 13 and negative 2. That's what we already saw, right? 13 and negative 2, 6 comma 13, 3 negative 2. So it gives you these points without having to do this math. And then to find the average rate of change, you could even graph it. So perhaps these points should show up on you. There's your 6, 13, and then our 3, negative 2 should be here. So you could count these. You have to be careful. No, each of these grid lines is 1, so you're even better. So you could do it the way we did it a second ago. Count up 1, 2, and then 3, 4, 5, 6, 7, 8, 9, so on, up to 15. So we know we go up 15 and over 3. So up 15 over 3, that gives you 5 as well. So there you go. You can do you. There's a couple on here that are not from the notes. I tried to explain those in a reasonable fashion. If you still have more questions, feel free to reach out. I'm always here. What else? This is going out to everybody. Chances are pretty high it goes out to all the other teachers. I don't know what they're doing. For me, if you have late work or anything, I'm still taking it, but with some conditions. Email me if you have questions. But that's about it. So until next time, deuces.